Okay, so I've been at it again. I've made another noisy little electronic device. Hopefully this time I've stepped the game up a little bit. Let's take a look at what I've done. Okay, so I've been messing about with some electronics again, and I've tried to develop and improve the kind of small electronic noise device that I'd made in a previous video. I can't say that this is a roaring success, but it is a little bit more interesting, I think, than the last version. I did actually have this mapped out on a breadboard for quite a long time, and I was making lots of sort of adjustments, and I'd kind of got it to a point where I felt like it was actually sort of behaving in a way that was somewhat predictable. It's a very sort of off-kilter kind of unpredictable sort of a beast to begin with, but I kind of had it working in a way that I was quite happy. So I tried to then take that design from the breadboard onto a strip board layout and put it into this device. And yeah, somewhere along the line, it didn't quite translate, and so it started behaving in a bit of an unexpected way. So I've ended up kind of I guess circuit bending my own device and just trying to make it work in as an interesting a way as possible. So I'm just very quickly going to show you what I've been up to and just give you a listen to some of these sounds that this thing will make. Quite crazy sounds, really. So essentially what I've got is two LM386 boards, so the same as kind of with the other device. And what I'm doing, thanks Jake for your input, what I'm doing is I'm sort of routing the output of one of these back into its own input, and that feedback loop is generating an oscillator essentially, which we can then control. And I've got two of these, and then I've sort of set up the routing so that one will actually interact with the other one. And I'm not clever enough to figure out how to do that in a deliberate way. So, I've been throwing components and different sort of signal path, options to try and see just what sounds interesting to my ears. Yeah, there's quite a bit going on here. Most of it's underneath this board, a lot of connections and wires and things. But in terms of components, it's quite simple, really. One other addition I've made is I've actually made some little DIY Vactrals, these things here. And what they allow me to do via these two mini input jacks is to have a CV input. Now, if you're not familiar with that, CV is control voltage. It's used a lot in modular synths and other kind of standalone synths. And it's basically a device that can output a signal with varying voltages, which another device can then kind of read those voltage changes and apply that to some kind of modulation or something else. So in this case, the CV going in, these voltage spikes are causing the LEDs to sort of light up. And inside this Vactral, so we have an LED and then we have a light dependent resistor. So when this light turns on, this light dependent resistor is reacting to the light or the lack of light to change resistor values. So those changes in resistance are being used to affect different parts of the circuit when we have CV coming in via the mini jack. So yeah, I would be using some 3.5mm cables like this to go in, and then what I've been using, if I can just bring it in, is my DS2, so the 2-wave outputs from the LFO send out control voltages, so I can actually get this to interact with this device. The implementation isn't amazing, but it does work. I'll have some examples of that in a little while. But yeah, that's essentially it. I thought I'd just introduce you to this and just keep you kind of updated on what I've been spending my time doing. Let's just have a quick listen to this anyway. So quite crazy sounds, really. Let's just so these switches basically change the way that the signal is being routed through the circuit, and it will give us some quite unpredictable raucous sounds, and we've got various combinations. Yeah, okay, that's just a quick taster. Some pretty crazy sounds. I've got 2 trimmers in here as well, which we can actually adjust the output gain of each oscillator if you like. And if we sort of vary these, the way that they interact with each other kind of changes as well. So we do get a little bit more variety in the way that it behaves, although it's to be honest, it's more of the same kind of crazy sounds, but it can be quite useful in some circumstances. Not the most musical of devices, but in some ways it can create quite a lot of interesting movement, and it's quite good for sound design stuff. Okay, I've been editing this video. I thought I was done with it, but I'm not entirely happy. I feel like I rushed the filming and I didn't really explain things properly. So let me just talk to you a little bit more about this device and how it differs from the breadboard version that I had. So the breadboard version went through many iterations and they weren't all successful, but I felt like I got it to a point where it was doing it was giving me quite a variety of different sounds. So in the sort of default position, if you like, it was giving me a drone oscillator, a continuous tone, and depending on where the potentiometers were set, we were either getting a single tone or we were actually getting 2 voices, 2 oscillators that we could then harmonize. We could find interesting intervals between them. It wasn't entirely intuitive. You had to kind of tweak these dials and play about with it until you found something kind of interesting. But then with the addition of the CV inputs, that was giving us some quite nice sort of droney tones with movement. And then when you engage the switches, so either, you know, this one or that one, or both together, it would actually give us, we would then start getting into the chaotic sounds. And depending on the combinations that we had with these two, it would give us a different kind of variety of sounds, and it gave us quite a lot of scope. All very similar kind of chaotic sounds, but I felt like there was a lot more variety in the previous circuit. So this is something I'm going to keep working on in the background. I'll probably do another video when I feel like I've made some progress, because I feel like there is quite some scope for this basic concept with better implementation to actually make this into something a bit more functional, a bit more usable and predictable in the way that it behaves. But I do like the unpredictability, so I'm sure that's going to still be part of it. But so yeah, I think one of the benefits of kind of working on devices like this is that it actually kind of pushes you to try and develop your skills. So, you know, my knowledge of electronic circuits, especially when it gets into the maths and the equations, I mean, that just fries my brains. But through these processes, I am learning, and having a project like this, and, you know, in trying to improve it, it's, you know, forcing me to kind of learn more about it. So I think it's quite valuable for that reason. So I will probably return to this subject when I feel like I've made some progress. I think maybe for now I need to concentrate on something maybe a little bit more musical, something a little bit more consonant and pleasing to the ear, but I'm sure I will come back to some of these some more noise devices in the near future. Anyway, back to the original video. What I would like to quickly do before I show you some more examples of this, I'll show you some examples of it working with the DS2, and also going through my new noise box through the delay circuit of that. What I would like to do though is just let you know that I've made a drawing for a wiring diagram on a strip board layout for a single oscillator using one of these LM386 chips. So it's nowhere near as complex as this design, if you can call it a design. But basically what it will do is it will function as a single oscillator using a single LM386 chip. If you're interested in maybe doing some of your own experiments with this basic concept, I've made that available for you. There'll be a link down in the description. You will need to put an email address in, but it is free unless you want to pay some kind of donation as a contribution. You're more than welcome, but you don't have to. It's completely free. There's a list of components that you'll need with all of the values. There's a very brief kind of set of instructions on how to make it, and with some suggestions of some modifications you can make to it. So if you're interested, go and check that out in the link. And yeah, I'm going to leave you with some of the crazy sounds that I've been making with this device. So until next time, I hope you're having a great day. Take care of yourselves, and I'll see you again soon.